Hello and welcome to my video, lesson 4.4 on surface area. So here we have a rectangle and a circle. Those are the two that we already know about. Rectangle and a circle, those are the formulas for them. So very simply, a rectangle is length times width, and very simply, a circle is the radius r pi r squared times pi, or pi r squared, and that's pretty simple. Okay, so we know that already. We've looked at that in previous topics, and so you should look at those if you don't remember those. But let's now look at surface area of a rectangular prism and a cylinder. So with a rectangular prism, first of all, we can see that there are a few things going on. First of all, there are now three dimensions to think about. We have width here, we have length here, and we have, maybe I'll use a different color. We have, because I'm going to use purple later. We have width here, we have length here, and we have height here. Or we have height here. That's right there, because that's a little bit easier to see. Okay? So length, width, and height. So that means that there are a couple different sides to think about. The first side to think about is length and width. At least that's the first one I think about. So the bottom and the top are both length times width. So since there are two of them, we do 2 times length times width because there's 2 of those areas. And then the other sides that we think about next are the length times height, or at least that's what I think about next, which are the two, whoops, let's do this again, the two sides. So from either side of our shape, and that would be 2 of those, so it's 2 times length times height. And last but not least, we have the front, which is width times height, and the back, which is also width times height. So we have 2 times width times height, because there are 2 of those sides. So hopefully that helps you guys get kind of an idea of what those different sides look like. I'll just highlight one of those. So that's the green side and the opposing side, so it's always the opposite side as well. This is the blue side and its opposing side, so this is the front, and the opposite, which is the back. And this is the top side, the purple side, which is also the bottom side. Okay, so that is the rectangular prism. That is the area for that. That's the surface area formula. So hopefully that helps you a little bit. Now let's take a look at our cylinder. Our cylinder uses 2 different area formulas. Instead of just pi r squared, it uses something else as well. So I'm just going to write this something else up top here because we do need to know it. The circumference, I'm just going to write circumference of a circle is pi r. No, 2 pi r, sorry, 2 pi r. That's the circumference of a circle. So we're going to need that in a second, because you can imagine if we pull this apart, there are actually 3 different sides here to think about. There is the top and bottom. Okay, so there's the top side and the bottom side. And those are 2 pi r squared, right? There are, again, 2 of them, right? And the pi r squared is the area of a circle, so it's 2 pi r squared. So the top and bottom are 2 circles, and we're going to find those. And if you think about our cylinder, we have this whole side, which kind of wraps around the shape. So if you imagine our circle, this circle here, this purple circle here, and it rolls over itself until this point is back on itself. So it's one roll of our circle would be a length, right? You can imagine that one roll would be a length. And we can measure that length with circumference, 2 pi r. Okay, so that's the length. And then this direction is just the height of our cylinder. So this is why we have the area the area of the the cylinder's side, 2 pi r, which is the circumference, times h, which is the height. Okay. Hopefully that gives you some idea of what we're looking at here. I can also try to draw out this one if I like pull it apart, the rectangular prism. So maybe I'll try to do that for you. So if we have this here, then we can have the two okay, and oopsies. I don't like that it does that. It does that when my computer screen is very hot. Then it sometimes doesn't get the palm rejection. Anyways, so you can imagine that if we pulled apart our circle, like our rectangular prism, it would fold out into this sort of shape. Okay, so let's try a question here, keeping in mind our formulas that we have just worked through to get. So Sarah has to paint a pillar with the top, which is called a capital, and a bottom, which is called a base, each with 1 foot high, 1 foot wide, 1 foot tall, which also needs to be painted. If the pillar is cylindrical and 10 feet tall, how much area is she painting? And I've given all these drawings to give a little bit more detail because we need to know how thick the pillar is as well, and that's what this top-down view will show us in a second. So hopefully between these 3 drawings, it kind of makes a little bit of sense what I'm trying to show here. If not, just pause it right now and try to grapple with what this actually would look like. But anyways, let's look at first of all the 3-dimensional drawing that I did here. At the bottom and at the top, there are basically cubes, okay, and inside there is a cylinder. The top and the bottom are touching things, so the very, very top and the very, very bottom do not need to be painted. Okay, this is going to be a very complicated question, but using exactly those same things we've done. So anyways, the top and the bottom don't need to be painted, so we need to keep that in mind. All right, so we're going to find the surface area of our cubes first, and then start working away at something. So let's just think about our surface area formula, our overall surface area formula. So surface area equals 2 times length times width plus 2 times length times height plus 2 times width times height. And there are 2 of these cubes, so I'm going to write 2 here and just multiply the entire surface area by 2. All right. We also have the surface area of our cylinder. So let's just figure that out. The entire cylinder, we're going to take away parts in a moment here, but let's find the entire cylinder first. So 2 pi r squared plus 2 pi r h. All right. So that's our entire cylinder. Now, we've now figured out the entire surface area of all the 3 different 3D shapes, but we need to take away some stuff that is extra. Okay, so first of all, I already mentioned this once, but first of all, there is a there's a bottom which is sitting on a floor, so we don't need to paint that, and there's a top which is sitting on the ceiling, which we don't need to paint. So first of all, we can get rid of one of those 2 WHs, okay? Just one of them. So we're going to put this whole thing together and start subtracting here. Surface area equals 2, let's go with 4, I'm just going to multiply the 2 in, 4 LW plus 4 LH plus 2 WH. Okay, but we now know we also need to subtract 2 length times width. Okay, that's for the top and the bottom. We also need to add 2 pi r squared plus 2 pi r h But now we need to do some subtracting of our circles. So we need to notice here that there are actually, here, let's just write this in orange so we remember which one we're actually getting rid of. Okay, and in purple. So inside here, you can imagine that the cylinder side is losing a circle, and it's cutting off a circle worth on the cube side. And at the top, same thing. So we're losing 4 sets of circles. So minus 4 pi r squared. 4 sets of circles that we're subtracting now. All right, so now we have our formula. We're going to simplify it once. Whoops, this should be a 4 here. We'll simplify it once, and then we're going to start adding in some numbers. So first of all, when we're simplifying, we can notice that this minus 2 is going to get rid of some of those, and we're going to notice that our minus 4 is going to get rid of some of these and actually have it in the negatives. So let's simplify our entire formula here. Surface area equals 2LW plus 4LH plus 4WH plus 2 pi RH minus, so 2 minus 4 would be minus 2 pi r squared. Okay, now we can start plugging in some values. So we're just going to plug in some values. L, W, and H are all 1. R is, important to notice, is 0.5 feet. So it's actually half a foot. And H is 10. Okay, so there's a few things we have to notice. L equals W equals the other H, capital H, which is all equal 1. Okay, so now that we do that, we can just 1 times 1 times 2 is 2, plus 1 times 1 times 4 is 4, plus 1 times 1 times 4 is 4, plus, maybe we'll do that all straight underneath, plus 4, plus 4, plus 2 pi RH, so 5 times 2, so 10 pi, minus 2 times pi times r squared. I'm going to have to use my calculator, or maybe not 2 times. Okay, so 0.5 pi. Okay, and now we're just going to add everything together that we can. So 10 feet squared plus 9.5 pi feet squared. And now when we calculate that out, you could have easily typed it into your calculator much earlier than me. I'm just being especially careful with my significant digits, but you could have just typed it in your calculator. Anyways, we would get 39.8 feet squared, which you could probably just round up to 40 feet squared. Alright, so this is probably the most complicated type of surface area question that you could possibly be shown, just because there's some subtraction things that you have to take a look at. But you will be given questions where you will have to do some subtraction of surface area. So this is very difficult, but it is I think it's still on the fair side of things. So I hope this video helps you understand surface area a little bit better, especially when it comes to rectangular prisms and cylinders. Good luck!